We're ready to wrap up our discussion of net present value. We'll talk a little bit here about using net present value, kind of summarizing some of what we've talked about, and we'll also talk about some of the advantages and disadvantages of net present value as one of the methods we have available to help us analyze these long-term projects, these long-term investment opportunities that we have. But we start with using net present value, and again, kind of recapping this. Generally, we're saying that any project that has a positive net present value should be accepted because a project with a positive net present value is going to increase shareholder wealth. And then kind of the opposite of that, if there's a project that has a negative net present value, that project should be rejected because it's going to decrease our shareholder wealth. So our general rule here is positive net present value we accept, a negative net present value we're going to reject. But we may have a problem as a company that we don't have enough money to invest in all of those investment opportunities that have a positive net present value. And so really when we say there's a positive net present value, we're just screening it. We're saying, yes, this would be a beneficial investment, and we're going to have to look at it further to determine whether or not this is one of those investments that we're actually going to be able to make, given the amount of resources we have available to invest. And so when we have limited funds to invest, and we can't invest in everything, one of the things that net present value is going to be able to allow us to do is to determine how much present value we're going to get from each of these projects. And we're trying to maximize shareholder wealth, and so we're most likely going to be making our investment decisions based on how much net present value we're getting from the amount of investment that we're making. We'll come back and we'll talk about this a little bit later as well, but we're using net present value to determine which investment opportunities are going to provide the greatest amount of return, greatest amount of increase for the shareholders of the organization. Now again, we've talked about how it is that an interest rate, the discount rate, is going to impact the net present value. The higher the net present value, the higher the interest rate that we use, the lower the net present value of those future cash flows is going to be. So a higher interest rate is going to cause those future cash flows to be smaller in amount. And so what this means is, as we increase the interest rate we use, as we increase that required rate of return because of risk, for example, that higher required rate of return is going to make it more likely that the project is not acceptable, more likely that the project has a negative net present value, because we're taking those future cash inflows and making them smaller. And the higher the interest rate, the smaller we're making those cash flows. And so a higher interest rate is going to make the net present value of that project lower. And at some point it's actually going to become negative. There's going to be an interest rate at which it's going to become negative. Now we can set up what is called an NPV profile to look at this. And so we just have some numbers here. We have our project. We have different interest rates and what the net present value of the project is. And as we can see, as that interest rate gets higher, the net present value of the project becomes smaller. At 20% hurdle rate, we have a very small positive net present value, but at 25%, it's actually a negative net present value. And so if we were to take these different results here, these different net present values, and put it in a graph, we'd see that at an interest rate of 0, it's very positive, and somewhere a little more than 20%, the net present value crosses over into negative. Okay, so the higher the interest rate, the lower the net present value of that project is going to be, which is why this is an adjustment for risk, because the higher we make that interest rate, the higher we make that required rate of return, the more likely it is that this high-risk project is going to become a negative net present value. So if there's a lot of risk, there needs to be a lot of return in the future to offset that risk. Now, just kind of wrapping this all up by looking at some of the benefits and the disadvantages, the advantages of net present value. First benefit, it's an estimate of the profitability of a project and the amount of change in shareholder wealth that would happen if we were to make this investment. Okay, nice dollar amount. It's easy to understand. $1 million is better than 100,000. The net present value method does take into account the time value of money. We are taking into account the fact that $1 10 years from now is worth less to us than $1 1 year from now. We can use net present value to adjust for risk by adjusting that required rate of return. The more risk there is, the higher we make that required rate of return. And so we're able to kind of take into account any specific circumstances about an investment. Okay? Higher risk, we can raise that rate, just kind of making it so that we're able to assess all of these projects a little bit more accurately, taking into account the reality of each project. And it also allows us to rank potential projects according to our expected return, the dollar amount of return. We can look at the project that has the highest net present value, next highest, and so on, which will help us make those decisions about which projects we're going to invest in. Now, there are also some limitations of the net present value method. One of them is that we're assuming that all of those cash inflows from the project are able to be reinvested at the required rate of return. Well, if our required rate of return is like a weighted average cost of capital, maybe that's the case. But if we start adjusting that required rate of return up for any reason, it's going to become less and less likely that we're able to actually invest those cash inflows at that required rate of return. So as we start playing with the required rate of return and that interest rate, this is probably not going to be the case. Also, since it's giving us an amount, a dollar amount or whatever currency we're working on, we're not getting a rate of return. We're not getting a percentage. And again, we have the situation where maybe we have $10,000 of net present value, but if we have to invest $15 million to get that $10,000 of positive net present value, that's probably not an investment we want to make, because that's a whole lot of investment to get a very small net present value. And this method doesn't do that for us. It's only giving us that dollar amount. Really, in any time we have assumptions, there's a risk that our assumptions are incorrect. Those cash inflows in the future, any cash outflows now or in the future, they may be incorrect. And if those assumptions, those expectations, those expected values turn out to be wrong, well then our initial calculation is going to be wrong as well. But this isn't so much net present value. This isn't unique to net present value. It's any time we're using expected cash flows, anything expected and estimated in the future, but we need to keep it in mind as a limitation. Also, our actual cost of capital may vary significantly from the rate that's used in our net present value analysis. Again, this gets back to that reinvestment rate. And also, cash flows that are beyond our originally expected lifetime are not taken into account in net present value. Okay? We say it's going to be good for 10 years, and this is what we expect in 10 years, but maybe the project's going to last longer than 10 years. It's going to last 12 years or 15 years or 20 years. And those cash flows for those future periods aren't included. But again, we have to make the best estimate. When we sit down and we do this at the beginning, we have to make our best estimate as to how long it's going to last. And we estimate 10 years. Well, it might be 12, but it might only be 8 or 7 or 15. Again, so we're making these estimates. We're doing the best we can with the best information we have available at the time. But all of our assumptions might be wrong. Those cash flows might be wrong, and the timing might be wrong. And so obviously net present value is not perfect. But it is a wonderful tool. It's a good tool. It's one of the main tools that we have to assess these investment opportunities, these long-term projects. And so you need to know how we're using net present value, calculating the present value of all of those future cash inflows, comparing that to that initial investment. Again, if we have a positive net present value, this would be a beneficial investment to make. If it's a negative net present value, it's not going to be a beneficial investment. This is just one of those tools we have available to determine whether or not an investment would be beneficial to the organization. So net present value is a big one, and we've covered it. We know what we need to know about it. Another big one, the one we're going to look at next, is the internal rate of return. And whereas net present value gave us a dollar amount, the internal rate of return is going to give us a rate of return as the answer, as kind of that value. And so the internal rate of return gives that interest rate, that return, whereas net present value is given a dollar amount. And again, these are different tools. We're going to use them. Okay? We've looked at net present value, and next we're going to turn our attention to the internal rate of return.